In the previous video, we have discussed about kinetic energy. So every object in motion will have kinetic energy. Now, this chapter, we discuss about work and energy. Now, I would like to introduce what is work and what is understood by work done. All right. This is the definition of work done. Whenever a body will do work when it undergoes displacement. Okay, this is the keyword here, displacement in the direction of the force, which means that not necessarily every force will do work. All right, we'll see in the examples later what it means by this. There are several types of work. All right. The most common one is the work done by a force. Whenever a force is applied to a rigid body, there will be work done with the condition that the body undergoes displacement in the same direction as the direction of the force. Okay, so how do you calculate the work done by a force? Is the multiplication of the force and the displacement, as here is the displacement of the body. That is the first type. The second type is the work of a weight. Okay, whenever a body undergoes a change of height. Okay, so for example, this is the initial position number 1, and because of the weight after the rigid body is being released, then it travels down or it goes up, and definitely there is a work done by the weight W here. So that is the work done by a weight, and this is calculated using this formula: minus weight multiply with delta y. So what is delta y here? Is basically the change of height in which the rigid body has traveled. So that is the work done by the weight. The third type is the work of a spring. Okay, so whenever the spring is stretched or compressed, there will be work done as well. Okay, work done by the weight is calculated using this formula: minus 1 over 2 ks2 square minus 1 over 2 ks1 square. So S here, S1 and S2 here is the elongation. The elongation or the compression. S1 here is the compression. Okay, we'll see in the examples later what does this means. And the last type of work done is the work of a couple moment. So whenever a moment is applied to a rigid body undergoing rotation, then you can calculate the work done by couple moment, which is um is equal to the moment multiplied with the change of angle. Okay, this is the angular displacement. All right. Okay, that is a little bit of the definition of work done. Now let's go straight to an example. Okay, a 50 kg wheel is subjected to a force of 50 Newton. If the wheel starts from rest, okay, this is a keyword, starts from rest and rolls without slipping, another keyword here. Determine its angular velocity. Okay, this is the parameter that we have to calculate after it has rotated 10 revolutions. Okay, the radius of gyration, so this is not a homogeneous solid, so the radius of gyration is given. The radius of gyration is KO equals to 0.3 meter. All right. The first thing to do is to draw the free body diagram. So this is the free body diagram of the rigid body. So we have a weight here. Mg is the weight. Okay. At the contact point, you have normal force, okay, and you have the force P, which can be separated into X and Y components. So basically, we are using the coordinate system X positive to the right, Y positive pointing up. And notice that I wrote number 1 here because this is the initial position. When we are dealing with work and energy, or basically work and energy method is used to solve problem involving distance. Whenever distance is mentioned, like here 10 revolutions, then we are going to use the work and energy method. So what happens after 10 revolution? Basically, after 10 revolution, the wheel has traveled somewhere over here. Okay, this the wheel has has translated to the right after 10 revolution. Okay, so what happens at after 10 revolution? We call this as position number 2. Okay, and we draw another free body diagram. So at position number 2, basically the free body diagram is still the same. All right. So how do we continue solving this? Okay, let's see where is in which direction the wheel has traveled. So basically the wheel has traveled to the right. This is the direction of travel. Okay, so if you look at the forces acting on the wheel, you will see that the force you will see that the force mg here, mg, as well as the force na, as well as the force p sine 30 is not doing any work. Why? Because these forces are acting in y-axis. These three forces, this is number 1, number 2, and number 3. These three forces is acting in y-axis. Okay, whereas the direction of travel is in x-axis. So the only force that is doing work in this case is this force, P cos 30. All right. So let me erase this first. Okay. So now we are saying that mg, the weight, the normal force Na, and the P sine 30, no work done. It's not doing any work. These three forces are not doing any work because the wheel is traveling in the x-axis direction, and these forces are in y-axis. Okay, these forces are in y-axis. All right. So what are the forces that is doing work? Only P cos 30, which is a force. So we are going to calculate the work done of a force. Okay, this is a force, work done by a force. So remember, the UF is equal to the force multiply with the distance S. So now we have delta S here. Now we have to calculate what is the value of delta S. So how do we determine what is the value of delta S? We have to use the clue given, which is 10 revolution. So in 10 revolution, what would be the distance S? So as you know, the wheel here has a circumference, right? So you need to know what is the circumference of this wheel. So how do we calculate the circumference? The circumference is basically equal to 2 pi times the radius. Okay, that is for one revolution. So when you have 10 revolution, so delta S will be equal to 10 times 2 pi r. So that is how you calculate. One revolution is equivalent to the wheel circumference, which is equal to 2 pi r. So this is equal to 0.8 pi, okay, 2 times 0.4 the radius. Therefore, for 10 revolution, it's 8 pi. So 8 pi is basically the value of delta S here, which is 8 pi. So then you have the work done by this wheel is 1088 joule. Okay, so that is an example. I'm showing you how to calculate the work done. We are not yet going into the calculation of the angular velocity. That will be covered in the next tutorial videos.